Hello, hello, hello. Back once again after taking a week off. Fusion Phil here at jitcadcam, kicking off yet again another Workflow Wednesday. I see a lot of you guys out there. Dylan, how's it going? Bogdan, Mateus, welcome, welcome, everybody and anybody. We always give this a few minutes to kick this off because more people tend to jump in at the top of the hour. I hope you guys are excited because we are going to be covering parameters and expressions today and how they can affect both the design side, even your cam side, and as well, there's even the ability to do some stuff in your post side if you know what you're doing. Now, for some of you, a few of these tips that we're going to go over today are a repeat, as you may see in a few of my other videos where we dive a little deeper. But I just want to show you guys the power that you have in Fusion, as well as a few things that I've heard on the down low that is possible, however, completely untested, because why not see how badly we could screw this up live so we could actually see if we could fix it as well, because that's why I think a lot of you guys are here. So go ahead, let's join in and let's see what we can do. So the very first thing I'm going to cover is I'm going to sit down and talk about parameters and expressions on the design side. So with that, we're going to go ahead and create my sketch, and I'm going to pick my plane. And now with that, let's go ahead and create a simple rectangle. And then I am going to dimension said rectangle. And the reason for this, as some of you may or may not have already known, is when you create a dimension or a data entry, it is logged with a D value. Now, at the lowest level possible, this is basically a parameter, right? We're inputting some type of material or some type of dimension at a level to be able to control what we are doing. So a very simple parameter setup might be is I always want my height to be 2 times my length, right? So if I went in, and I'm going to make this a solid number for those of you out there so you don't have to take your shoes off to count the 20. But let's just say, for example, now I want this dimension here. I'm going to click the 1 inch that I just drew. Now what you're seeing is D1 has self-populated because that was dimension 1. That was the first parameter I put on this part, right? Now if I just take that by nothing more than times 2 and hit enter, you will now see we have an FX 2.0, right? So again, if we go to 2, that makes 4. For some of you out there that I know, you guys are like me, we're getting into that realm of having to possibly use 2 hands to count this high, but 3 becomes 6. So again, at a simple level, that's going to conclude my video. No, I'm just kidding with you guys. As you can see, there's a lot of things you guys can do with this when we start to talk about doing things like a pattern. Now, I am going to extrude this and give it a 3rd dimension, of course. Let's go the other way and stay positive, right? It's not Friday yet. No reason to be negative. But now if I was to go in and do a rectangular pattern of my body here, right? And then we give it a direction. Again, everything we are doing here is an input field, right? So as you guys can see here, by placing my mouse, should have gave me a D value. I don't think it's going to populate that D value. I'll show you another way how to find this. But you can see based on a 17-inch length, I want a quantity of 3, right? Again, we could have said by spacing, maybe on 9-inch, or again, this is the fun of when you start to talk about parameters. We could say something like D1, actually, we're going to go D2 here, plus 1. And now we're starting to create more of an expression. Now, an expression is nothing more than basically a math equation to figure out terms on something. So as you can see here, if I wanted to maintain a 1-inch spacing between my actual bodies, I've done that by taking a dimension. And again, that dimension was the lower part of my rectangle. And I've done D2 plus 1, or in this case, 1 inch to create that actual expression, right? So as you can see, we could also do this upwards. I'm going to go ahead and drag this the other way. We're going to actually go outwards with this. And again, I'm just collecting several data points. Now, as you can see, if this is something you're going to find yourself doing quite a bit of on the design side of manufacturing, we're going to go up to the top under modify and we're going to get a deeper dive, right? So when we look at the change parameters area, this is our parameter table. So every dimension I have now input inside of this actual sketch, the extrude, the components, anything you're doing on design, again, a data entry location that has allowed me to create parameters and expression off those. Now, the real fun starts to happen is when you want to add variables for you to control. Now, a good one might be is a part length and a part width, right? So what I'm going to do here is I'm going to type in up at the top, and what this is going to be is my part width, and then I'm just going to do part W, and we're going to take that back down to 1, and then I'm going to add another one in for part length. Again, that's going to be 2 in this case. And then lastly, we're going to go ahead and add in a part W for width. Did I do W? I didn't do W. I did do W. All right, we're going to go T for thickness, right? So again, 1, 2, and 3 input, all based on inch increments. And I can start to plug that in. So what's going to happen now in the background, if I can get you guys a little better view here, is we are going to now use those parameters and plug them in basically as our expression, right? So here is part W. And then when I click off this, notice how all of my parts have changed. Again, maybe D2, we actually want to go back to that original system. We want to be part length. And then lastly, I would like to update this to part thickness. Again, as you're seeing, is based on all of that information, we can use that to our advantage. Now, again, we could add another parameter in here, and this could be spacing. Again, we're going to just stick with the basics here of 1 inch. Now we can go down to the bottom. Again, initially we were using dimension 2, which dimension 2 is now referencing part length. So we could put this back to part L, or we could leave it as D2. And this is where we could start to daisy chain our dimensions together, right? So again, now I'm going to do D2 plus spacing. And again, that gives us our 1 inch spacing there. The other direction, we're going to go ahead and say that's D3, lowercase d. Again, we're going to add spacing to that. And as you're going to see, anytime we now start to control small dimensions, we're going to control and reconfigure our arrangement of squares here, right? So again, if I go back up and we say this is 2, 4, and 5, as you can see, my spacing and everything has automatically updated and reconfigured everything on the fly. Now, the nice thing about this, as you guys are seeing, is because of the way we are setting up our parameters and controlling everything, we could also favorite things in this case. So instead of making a parameter for an actual number of parts, I could just favorite them. Again, if we go to 6 and 6, my pattern increases or decreases back down. Now, where this can be tricky at the end of the day is when we get into that world of creating a actual parameter that isn't necessarily a unit in measurement, it's an integer, right? So this could now be, you know, pattern, and we're just going to say number, we can't do number, pattern num1, right? Now I need to change my units to no units because this is always just going to be a solid integer, right? Like no decimals here, nothing of that nature. Again, we can plug that in down below. Actually, I'm plugging that in the wrong area. So we're going to go ahead and convert that back, which was D2 plus spacing. And then up here, we're going to plug in, again, that pattern, so forth and so on. So again, based on how you guys are doing this, this is where the real fun comes in because you're going to have times where you don't want a unit of measure because the way the math is going to work out on things. So again, as if we get into the actual spacing here, we initially use D2. But let's say, for example, I want to, again, not a perfect use case here, guys, bear with me. We're going to go ahead and say that's now D2 times, and we're going to go ahead and do our multiplication. And then we're going to add in pattern N1, right? So what can happen is, in this case, we did luck out because, again, the count here is the key element. So the count needs to always be a solid number. So if I was to plug in this case, let's just say part W, we are going to get that error where it cannot be utilized because it's a dimension. It's not a no unit figure. But again, the idea is still the same, that when you're starting to plug this information in and play around with these equations, there's a lot to be had with what you can and cannot do. So another use case here would be is if you were framing a wall, right? You have to start with a stud. You have a spacing of studs based on a length. All of that stuff you can roll up into simple expressions and parameters. Well, let's go ahead and pivot now, and let's jump over to the manufacturer side of this type of equation and expression use, right? So what I'm going to do is I'm going to jump over to manufacturer. I'm going to create my setup here. We're just going to go for simple milling. And what we're going to do is we're going to actually use all of the models in this case. But if you've ever done a jig or a fixture or a feature that is redundant and repetitive, you've probably done something along the lines of a pattern, right? So now at the level of pattern, again, you have the ability anywhere there's an input field inside of Fusion 360 is to click the three little dots and say edit expression. Now, from what I'm told, and it's already populated here, is if we knew our actual input values, as you guys are seeing, so we have our part L, part W's, even the call out of the D values that we've all put in, direction 1, again, direction type, all of this stuff, again, can be pulled through automatically inside the software. So in my case, I've already completely forgotten what I wanted to do. But let's say we want D2 or part L, and then we're going to say plus. That's going to be spacing. So again, as I'm just double clicking these to populate, and now the result is 127. So this is probably one of my biggest complaints when you start to deal with expressions, is the fact they all come through in millimeters each and every time, no matter what it seems to be on the side. So again, what we need to do is throw that possibly in some brackets and times it by 1 inch. And in this case, we get an invalid expression. Why are we getting an invalid expression? Well, it's because yours truly, based on a number integer, again, this is where we talk about a unit versus no unit type of setup. I can't actually put a inch value in here, right? So again, this is just me try to work through this kind of quick to give you guys some really good ideas here. But as you can see, what we actually wanted was our pattern N1, which is a solid integer, again, coming through from our design side. So now our quantity has updated to 3. This is, again, where we're going to go in and we're going to edit our expression here. And as you're going to see, we're going to go ahead and plug in part L. And then we're going to add in our spacing, right? Giving us a 5-inch spacing. And again, that's 3 across, 5-inch spacing. We're not going to worry about the second direction here. And what I'm going to do is we're going to actually go back because we need to perform a direction. So there's our direction. And we do need a toolpath to kind of see what in the world we're doing here. So let's, at a simple level, go ahead and throw a face mill at this tool. So again, my good old trusty VF2 area, we're going to find out, actually, this is going to work out good because I actually designed these parts, right? So I should know roughly how big they are. So there's my first toolpath. Again, based on doing these equations the correct way, yours truly has done them in the wrong direction, as you guys have seen. So we can fix that at any time. Again, the ability to utilize these expressions. So we don't want part L. Actually, we do want part L. I actually want to go this direction. And then I want to flip my direction. So as you can see, again, as you could start to set this up to create whatever it is that you need and auto-populate this type of stuff, especially if you're doing like a mighty bite jig and fixture with a lot of parts on it. Again, we can use the pattern we use for laying out the stock, cutting the jig, all of that stuff in our toolpath. Now, some of you out there are probably already questioning, what is it that's still wrong with this thing? And well, yours truly used part L. I believe that might actually be part W. In this case, it might even be part thickness. So let's see what dimension we have here. So that is a 6-inch spacing. And as you can see, now it lines up to my part as I was hoping for. So as you can see, the great thing is if we ever went back to design and changed things up in our parameters, again, we're going to go ahead and say, you know what, maybe we actually want to go with a case of 5 parts now. So now we're 5 by 5 rows. Again, actually, let's change our spacing up too while we're at it. So let's go back into parameters. So our spacing is now going to be 2 inches. And when we go back into manufacture, as always, you got to regenerate, obviously, your toolpaths and stuff to update everything automatically. And this is the fun of when you figure out that you picked the wrong part to start on, right? So as you can see, my pattern is always moving out and away in this case. And the first part I picked just so happened to be the middle of now my new configuration. So again, we can go in, we can make those changes relatively quick. I'm going to pick this guy over here. We're going to then check my pattern, which obviously we flipped it. So now we got to flip it back. And as you can see, we can realign that. So now if we were to redo this whole thing all over again, it's automatically controlled and automatically picking what we need. Now, this gets better and better as you start to work into more complex things, because a few things that people have asked me about, and some things that we did actually, I think on last Fusion Friday, was if I was making a part like this, and let's just say, just to cut down on how long it takes me to do a part like this, we're going to put our Z-axis up, right? So somebody was asking about something like a spot drill, right? I would like a certain size spot drill to go find anything and everything. Now, bonus points to you guys, if you could find the video, if it's still out there on Autodesk's YouTube channel, I did a whole video about drilling and tapping using expressions. But what I'm going to do is I'm going to say drill. We're going to go out and I'm going to pick my spot drill. In this case, it's a 1/2-inch spot drill, right? I am going to edit this, however, because you're going to see the value when you have a true spot drill that doesn't have a perfect tip on it. So let's go ahead and give this an 0.45 tip. And now we can, again, using what we know about expressions and parameters, you get to the right tab here, is we're going to do a diameter range. Now, if we wanted to write our own expression in here, it could very simply be tool_tip. As you guys can see, I have a tool_tip diameter. Again, its result is 0.45 inch. So maybe they did fix it. Maybe it is by default an inch now. And they did. This is nice. It used to always be millimeters and it used to drive me mad, right? So now my maximum diameter, we could edit again. And what that is going to be is, again, tool_diameter. And we need the maximum diameter. So we do need to stick with that. And then maybe I always want to be just less than that by, let's go 50, right? Here's where it is. This is the thing that drives me mad, see you guys. So when I type in 0.05 as an increment without IN, I knew it was still here. I'm not going crazy. I still have to follow it up with IN. And the reason is 1/2 inch minus 50 should be 45. But if we leave that as a solid number, again, what you're seeing now is it's actually converting 0.05 millimeters and taking that away. We're going to plug back in inch, of course. And as you can see, I'm now going to utilize that tool to automatically go out and select each and every one of my holes here. Now, what could cause a problem with something like this is, one, yes, I know we're picking up holes all the way through my part. It's just going to be a bad day. We possibly would have said a few more things as well. But the idea is still in here that if my spot drill is ever smaller than, say, 200, so if I edit my tool, and let's just say this is a 0.1875 diameter, right? 0.1875. And we hit accept. And if I try to regenerate this, what's going to happen is, one, it didn't regenerate. So let's do that one more time. It's not allowing me to regenerate, which is kind of always funny, right? So I don't know. Did I lose internet connection? Or, as it's not doing, which is kind of weird that it didn't give us necessarily a warning populated, it's just stuck in regenerate mode, but it can't find those holes on my part, right? Hey, Jeff, I see you out there. Great to have you here. Mateus, show that problem with flat milling. Mateus, this actual Workflow Wednesday, my guy, is not for actually assisting like our free support Friday stuff. And as well, you did not send me your part file. So you guys know, if you guys ever need support or you guys want to see more things in detail, feel free to reach out to us with the email links down below. We'd be more than happy to dive into that. So again, we're using an expression to control our toolpath based on tool diameter, right? This becomes very handy when we kind of shift gears one more time and we start to look at something like a lathe toolpath. Well, why would we ever want to do this on a lathe? And well, the idea here is at when we are doing something like a bar pull command, this is where the value comes in. So again, if I was to do a bar pull, I need to know a pull distance. And how I can auto figure that pull distance is because you have things like surface Z high. So based on my Z direction of my actual setup, and then we could minus something like surface Z low. Again, what that is now giving me is my total part length automatically. So again, when we start to think of ways we can improve our workflow to automatically generate a lot of this data based on our parametric model, I may still need to add something in there. And in this case, I'm going to go ahead and hit plus, and we're going to go 0.125 inch because that might be, you know, the thickness of my actual part off tool. Got to be a lowercase in, by the way. So now instead of 225, we're at now 2375. So again, that is my part off tool width. So now we're auto calculating pull distance on our part, right? So again, as if I was to go back the design here, maybe the part changes. We all know how engineers love to do us dirty like that, right? So let's go ahead and extrude this face here back a little ways. And now you've seen we've changed the length of our part, and we've also changed what surface was recognized, right? So when we go back into manufacture and I regenerate this toolpath, yes, we have a warning because we're still missing some stuff, but that length of pull distance has automatically updated again. So I know a lot of you guys are using the container method when it comes into doing things with the actual lathe side of things, and this is how we've started to work to make things like this much easier on people at the end of the day. Now, some really neat things that I've also seen is when we take up the idea of parameters and expressions, they're just data fields or ways to calculate math, is when you go and post out inside of Fusion 360. Some post processors have this by default, but if we went ahead and we actually look for the Autodesk dumper post, now I do believe I have it in here somewhere. So you need the dump from Autodesk. Now, what this is going to do is this is going to dump basically anything you can do with a post processor. So again, when you get into designing your own jigs and fixtures, and I have videos about, you know, Kurt Weiss's 2 of them, Op1, Op2 setup, I'm using parameters to control my stock size. Same rule applies when we start to talk about things like stock lower X, stock lower up, part lower positions. So if you wanted your post processor to even output your stock size or where your part is located or where your work offset is located, I've got a few videos on that. But again, same rule still applies. We're still looking for that parameter or that data and then restructuring it as we need. So with that, guys, I'm going to go ahead and end this video here. Like I've already said, if you guys want to see anything else outside of this or you have any questions at any time, feel free to shoot us an email down below. We're happy to look at your specific workflows. As always, you guys, likes, follows, and subscribes. We love them a ton. If you ever feel the need that you want to give something more, you're more than welcome to buy me a beer, which as a lot of you know, I drink quite a few of those. I keep meeting. You know what? This Friday, I'm going to show the receipt from the terrible time I had in Minneapolis airport. But outside of that, you guys can also buy your Autodesk license through us if you're in North America. And we do support just about anybody and everybody globally if you're looking for something like online custom training or in-person training as well. So as I always got to say, it's not what you know, guys. It's who you know, and you know Fusion Phil over here at jitcadcam. I hope you guys have a great rest of your day. Keep in mind it is Whiskey Wednesday, so have a good one.